Hello guys, welcome back to my channel Medicinal Pharma Education. I hope you're doing well and preparing for your exams. And in the yesterday's class, we have completed the TLC. If you like the video, just comment and tell you have liked it. Okay. And in today's class, we are going to start with the ion exchange chromatography. Okay, we have completed these two, and today only I will just complete the column and HPTLC. I've done the I've written the notes, and it has taken hours of time to write the HPTLC because it's very important for your exam. And I have included every single bit of information, and you have nowhere to go to find other questions. Okay, and you can find everything in this HPTLC video. Okay, it will come in today only I will just make the video and post it. Okay, for now in this video we'll complete the ion exchange chromatography, and in the next video we'll complete the column chromatography. Okay, stay tuned guys. uh, let's start with the ion exchange chromatography. No, the power has gone little bit. Okay, I hope you are seeing. What should I do? Should I start or what? You're seeing well. I don't think it's not clear. The power has gone. Okay, okay, I think so you are it's good without the power also. Okay, let us start with the ion exchange chromatography. Ion exchange chromatography may be defined as the reversible exchange of ions in the solution with ions electrostatically bound to some sort of insoluble matrix or stationary phase. See here in ion exchange chromatography, what is happening? There is an exchange of ions between the stationary phase and the solution ions. Okay, the ions in the solution and the stationary phase ions are exchanged. Okay, example, we have in the stationary phase we have negative ions, in the solution we have positive ions. Okay, here the positive ions are exchanged with the negative ions. Okay, that's the exchange the process. Or if negative ions are present here also, positive are present, due to their attractive nature or due to their displacement, they will they'll be replaced. Okay, they'll be exchange. There'll be there'll be two process: cationic exchange and anionic exchange. There'll be an exchange of cations or anions based upon the solution. Okay, and this technique is extremely useful in separation of charged compounds like protein differing by only one charged amino acid. So see, the proteins are charged molecules, right? Here, due to the charge of the sample, the exchange occurs, and the principle is based upon the charge itself. Okay. Next, if you have not understand any point, just comment me. In the next video I will just include the point. Okay, an ion exchange chromatography technique one can choose whether to bind the substance of interest or allow the contamination to pass through the column or vice versa. See, in this point it is telling that if you want the sample to bind to the stationary phase, we can modify in that way. Or else if you want the sample to flow and only the contaminations to bind to the stationary phase, we can do that way also. Okay, see here, if there are two in the mixture, we have two types. One is the required sample which we want, and the mixture which we don't want. Okay, these are the two conditions. Okay, and in this sentence it is telling that in the ion exchange chromatography, if the stationary phase we can make this one to bind, or we can make this one to bind. Okay, based upon the interest. Okay, based upon the efficiency. If you want to bind to this one, and all the mixture will pass out. If you want this one to bind, only the required sample will pass. Okay, based upon this mechanism, ion exchange chromatography is developed. Okay, now let us start let us begin with tell you the principle involved in ion exchange chromatography. See, I hope you are seeing clearly. Ion exchange chromatography relies on the attraction between the between oppositely charged stationary phase known as an ion exchange and the analyte. Here I said you right, there is an exchange between the charges positive and negative. Here positive attracts the negative or negative attracts the positive based upon the oppositely charged stationary phase. Okay, ion the ion exchanger consisting of an inert support medium coupled covalently to a positive or negative functional group. This is the mechanism or principle involved in ion exchange chromatography. Ion exchange chromatography. In that, first we will discuss the cation exchangers. What is meant by cation exchangers? Okay, possess negatively charged group and they will attract positively charged cation. Okay, these exchanges are called as acidic ion exchangers materials because these negatively charged result from ionization of acidic group. See, in the cation exchangers are like negatively charged group which will attract the positive charged group, because negative negative means it repels, positive negative means it attracts. Like charges repel, okay, unlike charges attract. That's the concept here. Okay, and it's telling that it's also called as acidic ion exchanges because there is an ionization of acidic group. Okay, that's why it is called as acidic ion group. In the cation, by this you can understand what is mean by cationic exchanges. Okay, I hope you have understood the anionic. Now see, anionic exchanges have positively charged group that will attract negatively charged ions. Okay, these are called as basic ion exchange because what is happening here, it is like ionization of acidic group, here ionization of basic group, so it is called as basic ion exchanges. That's the like concept behind the ion exchange chromatography. Now we will discuss the working principle of ion exchange chromatography. Okay, let me like this forms uh, this form of chromatography relies on the attraction between the oppositely charged stationary phase known as the ion exchange and analyte. We have discussed it. Okay, the ion exchanges basically contains charged groups covalently linked to the surface of an insoluble matrix. This also we have discussed. Okay, next, the ion exchanges basically contain charged groups covalently. Okay, I have written it twice. My mistake. Okay, charged groups of the matrix can be positive or negative charge. See, this is the principle because I'm telling like stepwise. If you have not understood the like starting part, you can like read it out, you'll like better understand. Okay, this is called working principle, and the principle and the working will explain both. Okay, when suspended in an aqueous solution, the charged groups of the matrix will be surrounded by the ions of the opposite charge. Means when the solution of the matrix is passed, the negative, if the stationary phase is positive, the opposite charge, positive means negative charge will be surrounded. Okay, if it is stationary phase is negative, positive charge particles will be surrounding it. Okay, in this ion cloud can be reversibly exchanged without changing the nature and the properties of the matrix. See, here it is a reversible process. Okay, and once they attach to the like once they form the cloud, and they like can be like removed. Okay, by the like elution, what we'll call like elution, right? We can remove the particles which are attached to the uh, stationary phase. Okay, and here is the like schematic representation of the working principle of ion exchange chromatography. See, initial stage is an initial buffer which use like initial buffer we use. This is the initial buffer which bind to the positive charge. Okay, here the stationary phase is positive. Okay, here the stationary phase is positive, and this is the like mixture but what like which we want to like analyze. Okay, yes, this is the mixture here, this one, different ions of the sample. Okay, and next initial stage, first next absorption of target. we are like absorbing the target. Absorption means it's not absorption, it's adsorption, AD, because it is happening on the surface. Okay, it is happening on the surface, so it is called as adsorption. Okay, after like this initial buffer is eluted out, we will, where the target is binded on the stationary phase. Okay, next starting of elution, we will again start the elution process. Okay, by adding this one, then the required first the triangles, here triangles are coming out. Okay, next end of elution, next total this they are like, see, first these triangles are coming out, next this rectangles are coming out. Okay, rectangles or cube are coming out. Okay, next lastly we will add again this one initial buffer to remove the required solution which we want. Okay, this is the process. There is nothing like complicated. First we will add the initial buffer which is bind to the stationary phase. The initial buffer is replaced by the mixture, and the initial buffer is replaced by the mixture. Okay, and we will again add the elution, we will start the elution, and the required samples will be coming out. That is the principle involved in ion exchange chromatography. Okay, see, I have like marked different for different things. Okay, the blue one is for starting the elution process, and the black one are the initial buffers, and the this triangles and the squares which are marked with the black pencil, these are the required ions. Okay, this is the process. Next, what we have next, instrumentation. Ion exchange chromatography instrumentation is not important, but if they ask, you have to like be ready to write. Okay, typical ion exchange chromatography typical ion exchange chromatography instrumentation include pump, injection column, suppressor, detector, and recorder. Okay, we'll discuss one by one each. Pump. The pump is considered to be one of the most important compound in the system, which has to provide the continuous constant flow of the elution through the injection column and detector. A pump means it's like pumps the mobile phase. Okay, next injection. Injection is to introduce the sample. A sample induction can be accomplished in the various ways. The simplest way to use an injection valve, liquid samples may be injected directly, and the solid samples needed only to be dissolved in an appropriate solvent. So here it is telling that the liquid samples can be directly injected, but the solids, firstly they have to be dissolved in the suitable solvent. Okay, injection should provide the positively injection sorry injectors should provide the possibility of injecting the liquid sample within a range of 0.1 to 100 ml of volume with high reproducibility and under high pressure. See, the injection, it is telling that it should provide a range of 0.1 to 100 ml, means we must able to inject 0.1 ml also or 100 ml also if we want to. Okay, that's the range it should be providable, and it should be highly reproducible, means if one experiment is done and the second experiment is also like completed, the like same result should be there. Okay, if here we have like got say one result, and the next result also should be same if the same what values are used. Okay, under high pressure, and here like if you are using the pump to like send the mobile phase, the pressure also increases. Okay, that's also it should withstand it. Okay, next the columns, depending upon its utility, ultimate use, and the area application, the column materials may be stainless steel, titanium, glass, or an inert plate such as PEEK. The column can vary in diameter from about 2 millimeter to 5 centimeter, and the length from 3 to 50 centimeter, depending upon whether it is to be useful for normal analytical purpose or micro analytical or speed analysis or preparatory matrix. I think so you have understood. Based upon the size, based upon the like length, we will select the sample which we have to analyze. It can be like stainless steel, titanium, or glass, and these are like common things. Okay, next the god column also you'll be using in the HPTLC, and you'll be using in gas chromatography, No, in the gas chromatography, I think so. We've not it. Just comment it if we are using the guard column HPDLC or not. Okay. I mean, in the HPDLC we're using, in the gas, I don't know. I have like not still completed it. Okay. The guard column is placed anterior to the separating column. This serves as a protective factor that prolongs the life and usefulness of the separation column. They are dependable. They are dependable columns designed to filter or remove particles that log the separation column. Okay. You have like read it. They are like used to like I mean stop the contamination. It may be like sol particles, or it may be like microbes. Everything which passes through it, like it is removed out, which are like impurities is removed out. It is used to like increase the like life of the separation column. Means because separation columns are very costly, right? If the impurities are contains in the like mobile phase or the solvent, it damages the column, and the column replacement is very costly. Okay. Next, uh, suppressors reduce the background conductivity of the chemicals used to elute sample from an ion exchange column, which improves the conductivity measurement in the ion. Based on that, suppressivity is nothing but reducing the background conductivity of the chemicals. Means if we are getting the result right, we are reducing the background, I mean background result, I mean background graphs which are like which means complicate the like graph, right? We are removing that by suppressing the conductivity of the chemicals, okay, used for eluting sample. Ion exchange chromatography suppressors are the membrane based devices which are designed to convert ion elution to water as a means of enhancing the sensitivity. See, if the like elute, if the samples, if they, we are using the solids, right, we'll must dissolve in the solute, and this may like increase the decrease the sensitivity. So for increasing the sensitivity and increasing the like process and increasing the like identification or the like graph, we use the suppressors, because if we don't use the suppressors, the reading will like varies a large, and there is like there this sample or the solvent used, these also like show the result in the graph, and it is very difficult to identify the compound, so that we use the suppressors. Next, reductors. Electrical conductivity reductors is commonly used, and data system in routine analysis where no automatic is needed. A pre-programmed computer integrated may be sufficient, and nowadays we are like using the computer based EROT devices where the computer directly tells the uh, result of the like experiment. Okay. Chromatographic parameters, and these are like not this much important for your exam point of view. I have like listed out chromatographic parameters: rate of ion exchange process, uh, flow rate, mechanical strength, swelling, particle size, porosity, selectivity, total capacity, ion exchange capacity, and cross linking. These are the like chromatographic parameters. Next, uh, factors affecting ion exchange separation. First, size of ions, valency of ions, concentration of solution, and concentration and charge of ions. Okay, we will discuss one by one. See, size of ion similarly charged exchange increases with decrease in the size of hydrated ions. Here it is telling that if you have the similar charged ions and exchange increases with decrease in the size, if the size is decreases, the exchange process increases. That's what it is telling. Okay. Next, valency of ions at lower concentration and ordinary temperature, extent of exchanges increases with increase in the valency. See, if the valency increases, the exchange increases, because if we have like highly negative charge or highly positive charge, they will bind more to the stationary phase. Okay, and the process, what is going on in the like what is the separation process going on in the like ion exchange chromatography will increase. In that way it affects. Okay. Next, concentration in dilute solution. Okay. Leave this third point, I have like included both one. Okay. concentration and let me on the flash. Okay, a concentration and charge of ions. Okay, see how like it is favorable. Okay, if the resin has a positive higher positive charge. Okay, if it has like higher charge or higher positive charge, and the solution has lower positive charge, exchange is favorable at higher concentration. This is the concept. Okay, like I can't explain. This is like between the like resin and the stationary phase and the like solvent. Okay, if it has like higher and the solution has lower, it is favorable to higher concentration. And if the resin has lower positive charge, the solution has higher positive charge, then exchange is favorable to lower concentration. Okay, like this is the like mechanism or the concept. Okay, we can't explain this one. Okay, next, the applications involved in the ion exchange chromatography: separation of ion inorganic ions, purification of some solutions to be free from ion impurities, softening of water, separation of amino acids, determination of basic composition of nucleic acids. Okay, in the applications, like it's basically based upon the charge. What are the like charges? If any separation which has like charge, right, we can like write this one. Okay, write the application in ion exchange chromatography. Guys, if you like this video, please like it, and please comment it what like which part of this one, like which part of my explanation did you like the most. And please guys subscribe, this will really motivate me. And everyone we are watching, please support me and tell it to your friends. Okay, thank you guys, take care, see you in my next class.